Okay, to begin with today, just to review from class on Tuesday, I would like you to simplify and evaluate the first one. So use the laws of logarithms. So you may need to look back in your notes, those 3 rules for logarithms, and then the second one as well. So see if I have them.
Good morning, Sabbath students. Currently, we do not have a bell program, so just please proceed with block 1, and hopefully we have it resolved by 9:40, or as Mr. Munn says, soon.
Okay, so these 3 rules, so remember you can look back at those in your notes, or if you have a formula sheet handy, to simplify these 2 questions. And I will pause the recording. So there's one way you could do the first one, not the only way, but I'm getting 2, and I saw a number of people were getting 2 as their answer for this one. Anybody have questions with this first one? No. So what I did was I chose to distribute the negative sign into the parentheses. Some people combine these 2 in the parentheses first, which is fine, and then you'd have a log base 3 of 10. And so then at this point, you just have a log base 3 of 90 minus a log base 3 of 10, which might be a little simpler even. But either way works out. Good? All right. How about for the next one? For this one, I think distributing the negative in is probably a good idea as our starting point. And so we'll have 2 log A minus 3 log B, and then the negative times the negative turns this into an addition of log C. So we dealt with the brackets, so we can think order of operations, got rid of the parentheses or brackets. Now I can deal with this multiplying. So again, using that 3rd law of logarithms, the 2 can move into the exponent, and this 3 can go into the exponent of the b. So log of a squared minus log of b cubed plus log of c. Any questions to there? Nope. Okay. Then, as we said in Tuesday's class, any logarithm that has a positive sign in front, using that 1st law of logarithms, I can write it as a single log, where those 2 will be multiplied in the numerator. And then wherever I have subtraction, that power ends up in the denominator. So that's what my final answer looks like. Any questions with that one? Yes. If we simplified inside the brackets? Yeah. The thing is that that will make it a little bit trickier because we'll have a fraction early on. So we'd have, let me do the log of a squared, so I'll bring that 2 into the exponent right away. And then I need to take this 3 into the exponent of the b. So that's what my first step would look like in that case. Then inside these brackets, because I'm subtracting, I can write it as a quotient, so log of b cubed over c. Because remember, a logarithm is an exponent. When we're subtracting exponents, it's because we are dividing these powers. That's all being subtracted from log of a squared. And this is where it gets a little bit tricky, because since I'm subtracting logarithms, I think, well, this b cubed over c gets divided. So writing it as a single logarithm, I'll have a squared, and I'll be dividing by this b cubed over c. And so I'm just writing division this way because if I'm dividing a fraction, I find it easier to write it with this kind of a division sign. And then we can remember that, oh yeah, dividing a fraction, I take the reciprocal and multiply, which will take us to the same answers we had before. The log of a squared times c over b cubed. Good? Okay, so that's what we did on Tuesday. And then we started into solving exponential equations, but we skipped a couple of these warm-up questions. So I'd like you to do these two, and then we'll get into some solving exponential equations again. Number one, everybody good with that? Just have to be careful remembering that because this 2 is positive, we subtract it on both sides. So don't let the sign behind it confuse you. Always think about the sign that's in front. So then this negative stays with the 3, and then we can divide out the negative 3. For the second one, anybody have an idea how to get started? Or what did you do? Michelle? The problem with that, if I took this xy to the other side, my goal is to solve for y, so I need a y in just one place. And when I eventually divide by y, well, I guess the y will divide here and divide there, so I'll just have one y under the 2, and then we could solve for y. So we could get there, but that's not going to be the most efficient way. So I'm not going to go through that way. Anybody do anything different? What if the question was just this part, and I asked you to, well, I guess it kind of gives it away. If I asked you to factor that, how would you factor it? Yeah, there's a common factor of y. So we could factor the y out, and then we'll have 1 minus x equals 2. And by factoring the y out, we get to a point where there's just one y, and now we can solve for that y. So we may end up the same place as you would have with your method, Michelle. But this helps us to avoid fractions earlier on. We're going to get a fraction as our final answer at this point where we divide both sides by this 1 minus x. We get y is 2 over 1 minus x. Sounds a little bit different because we can't simplify the two terms with the y initially, and so we have to factor the y out. Now, I think I put this question in back when I did more complex logarithm questions, harder than we need for this course. So this idea won't really show up in the logarithm questions we'll have for this course. But if you were to take Math 30-1, that idea is going to be important. Question number 3. This one we did on Tuesday. So remember, we just rewrote this in logarithmic form. And then we also wrote it as a base 10 using that change of base law. So at the bottom of the page, we put the change of base rule, which is if I have log base b of x, then that's going to be the same as the log of x over the log of b. So it's a useful rule to have. If your calculator works in other bases, then it's not a rule you'll need to use a whole lot. Then we did number 4, where instead of rewriting the same equation, so that equation is the same as what we had up here. In question number 4, we took the log of both sides. So we did the log of 12, the log of 3 to the x, and then we could use that law of logarithms to bring that x down and multiply it, because if I have this power raised to an exponent, I can multiply the exponents. So again, a logarithm is an exponent, so it's multiplied to this exponent. And then we finished off by dividing out the log of 3 to both sides, and we end up with the same answers we had for the previous question. Okay.